Hi friends, welcome back to another video. Today I'll be explaining Physics October-November 2014 paper 61. Question 1 states the IGCSE class is investigating the reflection of light by a plane mirror. Example figure 1.1 show a student's ray trace sheet. So this is a ray trace sheet on which you have to draw. So part A states figure 1.1 draw a normal to the center of the mirror. So first we will draw a normal line in the center of the mirror. So here they have already given us the mirror over here, and then you will draw a 90-degree in the center of the mirror over here, a straight line. Then part B states figure 1.1 draw an incident ray at 30 degrees to the normal and to the left of the normal. So we will use a protractor and draw a 30-degree line from the normal on the left side, and we will draw it till over here. Then in part C, figure 1.2 shows a diagram of the ray box. So this is a ray box. On figure 1.1, draw the ray box in a suitable position to produce the incident ray that you have drawn. So at the end of the incident ray, we will draw a ray box, which is over here like this in figure 1.1 at the end of the incident ray, or at the starting of the incident ray. So this is what we will draw here. And then part D states on figure 1.1 draw a reflected ray in the position you would expect it to be used to in this incident ray that you have drawn. So as this is a mirror, so the angle of incidence is equal to the angle of reflection. So over here we will draw a reflected ray at 30 degrees. So I have stated 30 degrees over here. Then question E states state 2 precautions that you could take in this experiment to obtain reliable results. So the first one is draw a thin ray by using a sharp pencil, and the second one is view the protractor perpendicular to draw angles. So these are the 2 precautions that you could take in this experiment to obtain reliable results. Question 2 states the IGCSE class is investigating the cooling of hot water under different conditions. Figure 2.1 and 2.2 show the apparatus used. So this is the first apparatus in figure 2.1, and this is the second apparatus in figure 2.2. Part A states record the room temperature QR as shown on the thermometer in figure 2.3. So this is thermometer, and over here if you look closely it is above 20 degrees and close to 21 degrees. So the Q Acosta R is 21 degrees Celsius. Then part B states a student pours hot water into the uninsulated beaker shown in figure 2.1 into this beaker until it is about 2/3 full. She measures the temperature and immediately starts a stop clock. She records temperature every 30 seconds. She repeats the procedure using the insulated beaker shown in figure 2.2. The readings are shown in table 2.1. So these are the tables that temperature that is shown, readings that are shown from figure 2.1 and 2.2 in table 2.1. Then over here question C states whether the cotton wool insulation increases, decreases, or has no significant effect on the rate of the cooling of water as compared with the rate of the cooling with no insulation. Justify your answer by reference to the results. So significant is no significant effect. Justification: temperatures are almost same within the limits of experimental accuracy. Then part D states the students suggest that a significant cause of loss of thermal energy from the beaker is evaporation. So just how you would reduce this evaporation in this experiment. First we will write is cover a beaker with lid. So this will reduce the loss of thermal energy from the beakers in the evaporation. Then question E states suggest one condition that should not be changed when this experiment is repeated. Start from the same initial water temperature. So we must start from the same initial water temperature. So this is what we will write in question E. And over here in table 2.1 of question 2, here we have to write with T is seconds, S, then Costa degrees Celsius, and over here with installation Costa is degrees Celsius. So this is what we will write in the table. Question 3 states the IGCSE class is investigating the resistance of a wire. The circuit used is shown in figure 3.1. So this is a circuit in figure 3.1. A student measures the potential difference V across the length L of the wire AB and the current I in the wire. The wire AB is 1 meter long. The readings are shown in table 3.1. Calculate the resistance R of each length L of the wire AB using the equation R is equal to V divided by I. Record the values of the R in the table. So this is the table 3.1. So we will use over here we have L centimeter, which is 10, and voltage is 0.3, and current, which is amps, is 0.73. So to calculate resistance, we will use this formula R is equal to V divided by I, and when we use 0.36 divided by 0.73, it is 0.49. So this will be for the first one at 10 centimeter. Then at 20 centimeter, 0.7 divided by 0.71 is 0.89 for at 20 centimeter. And at 30 centimeter, it is 1.1 divided by 0.73, which is 1.51. And then at 40 centimeter, it is 1.45 divided by 0.73, which is 1.99. And 50 is 1.8 divided by 0.72, which is 2.5. So this is what we will write in table 3.1 of question part A. Then over here, part B states plot a graph of R against L centimeters. Start both axes at the origin. So at the origin at 0 centimeter, it is over here. It at 0 centimeter, it is 0.49, which is 0.5. So at 10 centimeter, we will plot the point over here. Then at 20 centimeter, it is 0.99, which is 1. So second one will be over here. And then at 30, it is 1.5. So we'll write plot of point over here 1.5. Then over here at 40 centimeter, it is 1.99. So at 40, 1.99. So over here, and then at 50 it is 2.5. So over here at 50 it is at 2.5. So then you will use ruler and connect all these dots up till 0 0 to the origin. Then question C states state whether your graph shows that the resistance R is proportional to the length L. Justify your answer by the reference to the graph. So the statement is the yes. Justification is straight line passing through the origin, because over here it states whether the resistance R is proportional to the length. Yes, because as the length increases, the resistance of the graph or of the circuit will increase. So this is the justification. Then question D states suggest how you could further test your statement in C using the same apparatus. Take additional readings at length from 60 centimeter to 100 centimeter. So this will also increase the experimental accuracy of the figures. So this is what we will write in question D. Question 4 states the IGCSE class is determining the magnification of an image produced by a lens. The apparatus is shown in figure 4.1. So this is the apparatus in figure 4.1. Figure Part A, Part 1 states on figure 4.1 measure and record the the distance u from the illuminated object to the center of the lens. So we have to measure the lens from here till here, which is 18.5 millimeter. Then part 2 states on figure 4.1 measure and record in the distance v from the center of the lens to the screen. So we will measure the lens from here till here in millimeter, which is 55 millimeter. Then question B states calculate the ratio V divided by U. So we will use V, which is 55, divided by U, which is 18.5, which will be 2.97. So the ratio of V divided by U is 2.97. Then question C states the diagram is drawn 1/10 of the actual size. Part 1 states calculate the actual distance u from the illuminated object to the center of the lens. So if the diagram is drawn 1/10 of the actual size, so we'll use the value of u in above, which is 18.5. So write 18.5 multiplied by 10, which will be 185. So the value of u will be 185 millimeter. Then part 2 states calculate the actual distance v from the center of the lens to the screen. So the value of the v over here is 55. So we'll write 55 multiplied by 10, which is 550 millimeters. So the value of v is 550 millimeters. The question B states measure the height h from the top to the bottom of the image on the screen. So this is already shown by the already solved. So this is 4.5. The height is 4.5. So over here I part 1 states on figure 2.2 measure the height x of the illuminated object. So this is the first size and you have to measure the height. So over here what we will do is measure from the top point and to the bottom line over here in the middle, not over here or here. It should be in the middle. So the length is 1.4. So the height is 1.4. Then part 2 states calculate h divided by x. So over here the height is 4.5 and x is 1.4. So 4.5 divided by 1.4 is 3.21. So the ratio is 3.21. Then question E states the magnification of the image is given by the equation m is equal to h divided by x. The student suggests that a ratio v divided by u also gives the magnification m. State whether the results support this suggestion and justify your answer by the reference to the results. So the statement is yes. The justification is it is within the limits of experimental accuracy because over here h divided by x is 3.21 and over here v divided by u is 2.87. So it is within the experimental accuracy. Then F states state 2 precautions that you could take in this experiment to obtain reliable results. First is the height of the object and lens should be the same. Second is always keep a meter rule parallel to the lens and the screen. So this is what we will write in question F. Then question G states the image on the screen in this experiment is magnified and dimmer than the object. State one difference that you would expect to see between the image and the illuminated object. The image would be inverted. So first is the image will be magnified and dimmer than the object and also it will be inverted. So this is what we will write in question G. Then in question H, suggest one precaution that you would take in this experiment in order to focus the image as clearly as possible. First is perform the experiment in the darkened room. So this will help the experiment in order to focus the image, because in a lighted room the object will be dimmer. So in a darker room the experiment should be performed in darker room so that the image could be more focused and, and as clearly as possible. So this is what we will write in question H. Question 5 states an IGCSE student is taking measurements of a Drake's cup. Carry out the following instruction referring to figure 5.1. So this is figure 5.1, and in question A, part 1, on figure 5.1, measure the height each of the cups. So we will use a ruler to measure the height, and it is 9.1 centimeter. Then figure 2, part 2 states on figure 5.1, measure the diameter dt of the top of the cup. So the diameter over here from dt, which is from this point to this point, and the length is 6.9 centimeter. Then part 3 state on figure 5.1, measure the diameter dB of the bottom of the cup. So over here the dB is from here till here, and which is 4.3 centimeter. Part 4 states calculate the diameter dA using the formula dA is equal to d1 plus d2 divided by dB divided by 2. So this will be dA is equal to dt2 plus dB divided by 2, which is 4.3 plus 6.9 divided by 2, which will be 5.6 centimeter over here. Centimeter. So dA is 5.6 centimeter. Then part 5 states calculate an approximate value for the volume V of the cup using the equation V is equal to pi d square by dA square h divided by 4. So which is V is equal to pi dA square h divided by 4, which will be pi multiplied by 5.6 square multiplied by 9.1 divided by 4, which will be 224. So as it is a volume, so we'll write 224 centimeters cube. Then over here, part B states the student determined the average circumference of the cup using 50 centimeter length of string and a meter rule. Figure 5.2 shows how the student used the string to determine the average circumference. Describe how you would use the string to obtain a more reliable value for the average circumference. So the first one is measure the circumference at the top and at the bottom by wrapping the string at two different positions. Divide both circumference by 2 to get the average values. So this is how you will calculate the average circumference of the cup more reliably. So this is the final answer. Then question C states the student fills a measuring cylinder to 500 centimeter cube mark. He pours water from the measuring cylinder into the cup until the cup is full. Figure 5.3 shows the water remaining in the measuring cylinder. So he filled the measuring cylinder till 500 centimeter cube and has filled the cup with this amount, which is now in the cup. So part 1 states record the volume water we are remaining in the measuring cylinder. So over here it is between 200 and 250. So it will be, and it is at the lower of the meniscus, not at the top of the meniscus. So this will be 225 centimeter cube. Then part 2 states calculate the volume VW of the water in the cup. So VW is equal to V minus VR, which is over here at the starting we had 500 and now we have 225, which will be 275 centimeter cube. So you will write VW, which is 275 centimeter cube. Then D is on figure 3.2, show clearly the line of sight required to take the reading of the VR. So we have drawn a dotted line in between 200 and 250, and stated we are from where we will measure the. So for taking a reading, we should not measure from the upper of the meniscus. We should measure it from the lower of the meniscus. This is the final answer.